Hi there, and welcome back. So let's get our hands dirty now, the hands-on session. So basically, the first case will be this case, the flow about the cylinder. We define the geometry there. Then in this box that I created there, I want to do the refinement, and this is how my domain will look like. Okay, so my external domain, then we impose boundary conditions, so on. So very basic case. Okay, but just to show you the workflow, remember I stress a lot, do your geometry, understand well your geometry here, you know, all your dimensions, everything. Okay, then you export and can do the mesh. So basically this is the external flow mesh, and this is what we're going to do. You download your case, see that, put your geometry there. You have your background mesh domain. So remember that you have that information from your CAD, you know, the coordinates, and then we start the measure. So you have the cylinder. In the cylinder, you have sharp angles. Okay. So it's up to you if you want to resolve those sharp angles. You want to resolve, go like this. If you want to resolve, there is an option. You can do more refinement. You can add the refinement region and so on. Okay. So we're going to see, remember that if you don't have sharp angles, no need to do that step. Okay, then I'm not going into details, then we go hands-on, but here you have explanation of these options, no? So refinement, the features, and so on. Here are some comments, very important. Please read this one, no? How to control scenes, how the angle is measured, okay, in reference, and so on. Okay, this option also very important. Now, if you want to refine inside the box, you have these two options, and this is very important to do refinement surfaces. Now, this is refinement with a surface on top of another surface. We're going to clarify what is the meaning of that later. And look at what we have here. We enable the feature edges, but look at that here and telling that the angle to resolve is 110. And see, obviously, this angle is less than 90 is not going to capture. Here, 60 and capture. So this resolve feature angle, it will resolve intersection between surfaces. Imagine that you have the main surface here and this face, you have this intersection that is less than 90, but also will resolve curvature. So if I go here and look at here that now I put refinement level of 4, it will add more refinement in this intersection, but still the curvature is not resolved because clearly this curvature, this resolve feature angle is lower. So see that if you put 5 here, start to control curvature and so on. So this is a little bit something that I don't like. I have to check if they added the developers this option because this angle, it will control the sharp angle, but also the curvature. Okay, I have my own implementation that I added an additional resolve feature angle to have this independently. It's not that it's going to change your world, but in some cases for me it's helpful. But any case, I have to check that with the developers, with the official version. Or if you know that it has been already implemented, if I am missing something, just let me know. And then, well, more options. So here you can see that a very simple case, but you can play with these options to control surface refinement and so on. Okay. Then how do you capture these surface features? Okay, so you have this utility you define here. You just give the name. Remember, the file is always located in constant geometry, and here you give this angle. So a little bit confusing how to work this one. Usually you have many options. I'm giving you the most important options. I will show you how to do it better using paraview, how to define this angle, but basically it's the definition now that kind of you have here, okay? You can detect that also, okay, here. Okay, here you have how it is measured, okay? So here you have the explanation, okay? And then also you can read multiple STLs in a surface or different blocks in that file. So here you have that small tip, a practice. And this is how it's done with paraview. This is the way I like to do it. And I will mention something about this angle and how to do the conversion. And well, then we go and we do the meshing, some steps and so on. Then you have here all the boundary layers. As you see, this can get very, very complicated. Small cases, small, simple cases, but it can get very complicated. Then we're going to do the 2D case. So let's split this one in 3 or 4 videos. So let's do the first part, okay? So let me see. I am here. So you should have this case, the cylinder case. Okay, you have C1, C2, C3, C4. So let's enter in C1. Okay. Dun, 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 dun. So N1, C1, you can put this whatever you want. You can extract these tutorials. Let's go C1. Okay, so the first thing, remember, geometry, always you have it here. Okay, so you have, this is your surface, and this is something else that I did a selection. Later, I'm going to show you something else. So let's open first paraFoam, just to take a look at the geometry, okay? Ignore this error, this warning, you don't have anything, basically. Go constant geometry, open the STL. So this is the STL. The first thing is that I want to point out that this is a single STL. See that the color is uniform, meaning that I didn't split this STL in different surfaces. C3, I'm going to show you know how to create those regions, okay? That are extra steps. However, what I want to show you here is that the feature edges, see that you have those chart angles there, can be computed here. And I like to do it here, and you can do some selection here. So if you go here, you should have feature edges, and see that you have it here. Apply, and you have it there. Those are your edges, okay? You can increase, let me see, okay, advance here, so, and like width, let me put 3. Okay, there you go. You see the lines there, okay? So those are the edges. So basically this one works. So see that if I put something more than 90, nothing. I go 90, probably yes, probably no. There you go, it capture. And the smaller, the more features are going to capture. So it's 10. So now if you put something very small, it's going to capture also curvature in the surface. No, so let me see if I put 1. See here. So this is telling you that between these faces that you have in the surface triangulation, the angle is less than that. Okay, so as you put 1, see that it's going to refine all those lines. So it's up to you. So usually a good value is 30. Okay, but here visually you can play with that. I want to point out that you can also extract those edges there. I'm not going to go into details. You can do it here. That will be another video. Okay, but the thing is that this angle that you put here, okay, and now let me go into system here. See that in system you have surface features open there. So see name of the mesh, and then here you have this angle. So for some reason, okay, it is the complement what you put here. Okay, so if in paraview you use 30, here you put 180 minus 30, 150. Okay, so use different reference, the developers, but the concept is the same. So here, see that we have 2 features also. See here, but we also add here some refinement. This one using, so when you put it here, you can have different values. Okay, you can put something like this. So it's up to you. So this is how it works. Okay, so see that now. Read my geometry. I identify my angle. Okay, by having a visual reference. So just to go back, that actually you can have visual references now. You can have onshape, you can have paraview, and so on. So let me close here, and let's do the next step. Okay, so the next step is to use surface filters. Okay, there you go. So this one, it will read the files, the surface, and it will extract everything according to that criterion. And as you go here into geometry, see that you have this image file. This image file is where you have all the information that later you're going to use in a snappyHexMesh. Again, it's human readable. and it's very easy to modify, okay? So you can give here connectivity, the locations, and then the connectivity. So this start vertex 0, 1, 2, 3, and here later you have connectivity to form the edges. So you can actually create the files manually, or you can modify those files. Here also you can have you have the objects, so what was extracted, you can visualize. So let me show you again. Okay, so you want to be extra sure what was extracted. So if you go here, constant image, surface, obj, and change the color, bam, 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 bam. So see that surface feature extracted that. So this is what is going to snap. And then just to show you that I have another file here, selection one, I also manually created some selection, and see that I can apply the same refinement in this selection. Okay, so later I'm going to show you this extra step. Okay, that is another video, next video, to show you that. I don't want to overcomplicate this. So basically I know that I have my edges, everything, and the next step is to do the mesh. So remember, first we need blockMesh to create the background mesh, and then you have a snappyHexMesh. By the way, you have here commented, so this is the one that you open. You have a lot of comments, you can get lost there. And then I put the clean one. The clean one, not many comments, very straightforward. So go ahead and open that. So remember, let's go blockMesh. It will do the mesh, and I don't want to go into details in blockMesh. This is a template that I have just to show you what I do here. Everything is parameterized. So I know the dimension of the domain. How do I know my domain has this dimension? Remember, you know your geometry. And that's what it is very important to have. So if I click here, see that here I have my coordinates. I can go here, get the coordinates of each one. I put it there, x min, max, y min, z min, and so on. The delta x, the spacing of my cells. So recall your slice. So will be this. So this, the delta. I know the delta, refinement level, and you can get the length. Okay, then this is inline computation. So just take this that you declare there, you do the inline computation and compute the number of cells that you need there. So this is, as I mentioned, is a template for me. Okay, I just change the minimum and maximums, the delta x that I want, and everything is done automatically. Then the patches, I name it by default like this, and then you can change everything, okay? So this is my specific block mesh. Later there will be a video about this. This block mesh also works in this specific reference system because it can be a little bit tricky, this block mesh, how things are oriented, but I use it always, okay? I don't need to modify it. So basically this step, if I go now paraFoam, it's not going to complain and see that what we have here now, it is a block mesh. I haven't done anything. Let me go wireframe. Basically, at this point, what we have is this. I have the block mesh, and remember that I need to put inside the geometry. And this is what we have. The geometry, but we haven't done the meshing top to bottom. And talking about visual references. Here now you have a very good visual reference how things are going to look like. So also there will be a refinement region there that I didn't create the STL. I will use an internal object in snappyHexMesh, but if you want, you can rig the STL and know I have that reference there also. So this is what is happening, okay? So the next step will be do the meshing. So I hope you're getting the workflow. So basically what happened is this. Block mesh, geometry STL, we put it together. Everything has been overlapped. It's like this. And now we start to do edge, surfaces, location in mesh, region, and so on. Okay, so now we move to a snappyHexMesh dictionary. So as you look at here, first block, okay, so here I'm selecting all the steps at the same time. Remember that this iterative, so you can go like false, do this one, then you can do restart. That is very important. Then we check that one. So false and start from here and so on. Okay, so you can control everything like that. I'm going to do all the three steps in one single iteration. Break the geometry. Very simple geometry. As I say, I hate this format of geometry, the STL. I don't like it, but also it's a human readable. So see that solid, you give it a name, and then you have the triangulation, the surface triangulation with normals and so on. So in theory, also you can modify it, or you can write a program to write your STLs and so on. So read the STL. Here I'm creating the internal entity that I mentioned. So recall, and by the way, remember the trick. You misspell something and you go snappyHexMesh and see that you have all these options of objects that you can create. So basically here, searchable box, give the minimum, the absolute minimum, absolute maximum. So you have to go from minimum to maximum, okay? And that's all. So this is the entity that you are given this name. So you go to the slides. In the slides, you are going to give no detailed explanation what is happening and whatever. I don't go into details there. So this name and this geometry that you are reading this STL, you are giving this name. So now you move into castellation. So here, default option. So remember that this stuff is limiting my mesh to 2 million. So if by any chance you choose a large refinement rate or whatever, and if you go reach this value, it's not going to add more cells, okay? So be careful about that. So put a large number there. It's up to you, but yeah, just to illustrate. Okay, then this is the buffer layers, the transition between cells, no? Okay, sorry. The transition bit is this one, okay? And these are stuff related to parallels, so this is not important. Okay, this is important, remember, for the curvature, okay? This one works in the same way as in paraview, okay? And it is the complement. So in paraview, you found 150, here is 30. And the idea is the same. The smaller, in this case, the more features you capture. Remember, this will capture intersections of surfaces in your STL and the curvature. So the triangulation, everything, according to that angle. So here you go into features. So features, this one, remember, you use surface features, you compute this image, okay? So as you go back, surface features, okay? It will save with the same name, and now level is a refinement level. 0 means that forced to snap to the edge. Do not add any refinement, but if you want, you can add refinement. And then you have this really cool, nice option, okay? Later you will see in the next video, I will show you that one that you can control by distance using this keyword levels. So the first one means distance, and the second refinement. So you put this one here, in those edges, a distance of 0.1 from those edges at a refinement of 4 in both directions, no? On the surface. Later we see that. So these are the features, first step. Then on the surface. So I know that the surface has this name, you have it there. And now that you have that name, you go and add surface. So first one, this is global, and then for curvature. So as you add according to the curvature or the intersection, add more cells, up to you. So this, I will leave it to you to play with these options and you will see the effect. But basically what you're going to see all this stuff, different options. So feel free, get familiar with the options. So I like this case, you will see that it's super fast. So play with that. Then refinement regions. Okay, so we're in the surfaces. So the surfaces, this option will grow into your domain. Okay, so the surface, then the region. This is the volume. So refinement box, I call it here, refinement box. Whatever name you give there, you keep it. Refinement regions, refinement box. What I want to do, inside that box, add a refinement level of 1. Similar to the previous one, you can use levels, but be careful that levels, you use it with distance, and later I'm going to mention when on why you want to use this one, know the advantage of this one. Okay, so don't get confused. Let's use the most basic option. Location in mesh. So you have this point, and this point will be outside the body. So just to do some visualization here, just to show you. So what is happening so far, I refined. So let me go here. Okay, we have this. Let me open here. The geometry. Bam, 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 bam. You have your edges also. And then let me add a source, Fear. That source will be 401. 401. 01. So you at that point that I don't see it. Where is that? Okay. Radius. Okay, it's there. I put it. It's 4, not 40. Okay, so radius 1. And see that what is happening, that I put a point. The point, it is outside of the body, so meaning that it's going to mesh outside of the body. If you put it inside, it's going to mesh inside. For those that use ISNCFD, same idea. I'm not going into more details, but same concept. So there you go. This is how you control. We define the exit refinement. We say that it was 0, so it's going to only snap. It's not going to refine this base cell. We define the surface refinement. We say that it's 2 2, and we created a volume around the body that is going to split with 1. And there you go. Then these options, as I mentioned, template. This most of the time it works. If it doesn't work, use the recommended value that you have in the slides. I mentioned my optional values just to increase iteration, but don't waste time here. If you want, probably I can go prepare another video to go into details what is happening, but it's just more iterations to make your body fitted mesh. And now we go into boundary layer. So boundary layer again, layers. Where do you want to add it? You want to add it in this surface. See that you gave it this name. This name is also used here, okay? And also here is also used here. Later I will clarify something because if you have regions, you need to use another name. Number of layers, you put it there. I want 5 layers. You can also add these options. You can add it locally. So this is locally and this is globally. Okay, so I can go and put it locally. So you have different walls, they can have different options and so on. So I put it here. This is locally, globally, and there are different expansion ratio, first layer thickness. I'm not going into too many details here because I prefer the second tutorial to talk about that. But what is important here is relative sizes. So true means that all the boundary layer mentioned is relative to the cell size. It's not absolute distance. So this will be okay, minimum thickness or first layer thickness is 0.1 of the cell size or 10%. So your cell size is 1, the first layer thickness will be 0.1. Okay, something like that. However, it is the cell layer thickness, okay? It's not the cell base if after refinement. Also to clarify that, okay? So see that now in my wall, I have this cell. So here was 1. Now this cell is becoming 0.25. It's going to be 0.25, okay? It is relative to the cell next at this point, okay? So that information, all that stuff is safe in OpenFOAM. Later in one tutorial, I think we're going to encounter that file that keeps that information, but in any case. And that is, okay, this is what is happening. So you define relative, so there are many combinations. So see that also different combination, first layer thickness. Also, I invite you to play with these options in these slides. You will see that I put different combinations and so on. You can get a feeling how things work, okay? You already know that this is tricky to control, but we're going to get there. So I'm not going into details. So for this specific combination, I need to give these options. Then all this stuff, leave it as it is, nothing to change that. Then here you have the mesh quality. So mesh quality, see that is kind of include file, save in a different file just to reduce the amount of clutter in this one. And there you go. So these are my preferred quality metrics. Okay, so this is how I put it, but it's up to you. You can, if you put here 80, OpenFOAM will do more iteration or snappyHexMesh to reach that. Okay, so depending. So if you put a really low value, okay, not necessarily will get that one, but it will do a lot of iterations to improve that, okay, to get to those values. So these are my recommended values. Then if you have problems later, we're going to see that you can start to switch off scenes. But this is how scenes works. As you see, it's very straightforward. So and also at the end, you have these options. It's going to print debugging, and later in the Wollər Dynamics logo, we're going to see how to use that. But nothing important. So see when you remove all the clutter and comments, it's straightforward. What you want to do, read the geometry entities, then you know the name that you have here, and just access features, access surfaces, access regions, put your point, and then this remains the same. Access the face and add the number of layers. A little bit tricky here is how to get to grow a small boundary layer, but it can be done, and that's it. Straightforward. So let's go and let's do it. Okay, so remember that we have the automatic scripts. So I run it like this and put it there, and see that are very linear. Okay, I don't put any programming, so here you're going to see all the stats. So blockMesh, surface features, snappyHexMesh, and check mesh quality. Important here that in the snappyHexMesh, I'm not using this auction override, and you're going to see what we're going to get. So, okay, look at that here in Control D, I'm using a delta T of 1. Okay, so what is going to happen that it's going to do everything, blockMesh, surface features, all the previous steps. Okay, look at that, it's very fast. So I invite you to play with all those options, get familiar. And if I type ls, see that you have three directories, 1, 2, 3. Why 1, 2, 3? Because you have here the delta T 1, 2, 3. So you put something else, will be according to that. So what you have in one is castellated mesh, body fitted boundary layer. Okay, so remember that these steps, you can switch on the steps and so on. You can control that. So what is happening? Let me add here. Okay, actually, let me go here. Load state. Okay, and there you go. So see that first step, second step, body fitted, boundary layer. That's it. Recall that we added the region there. Okay, so a box around, and recall that we added a transition of 3 layers, if I will recall. Uh, Let me go 3 layers here. You see the 3 layers, know how it's transition. So there you go, very easy mesh. Okay, something that doesn't take much, very fast, but I invite you. Try to play with all the options, and then try to play to generate very fine boundary layers, and you will see that you are going to encounter problems. Okay, so there you go. I hope with this tutorial you get an idea of everything. By the way, also you have the surface triangulation. Though, let me go here. Let me put the I'd say that in the surface triangulation, in this case, we didn't add anything, but if you follow here, these different combinations, you can add more refinement in edges and so on. You can get results like that. So feel free to play with all the options. So I hope you got a good idea what is happening. So we have an extension of this video to show you a little bit more advanced options. So see you next time. Bye.